Hello students, good morning one and all. Welcome to today's online class. So in last session already I discussed about problems on complex number. In that problems, one problem is remaining. That problem is x square plus x divided by root 2 plus 1 equals to 0. Now for this equation we have to multiply root 2 on both sides. That is root 2 x square plus x divided by root 2 into root 2 plus 1 into root 2 equals to 0 into root 2 is 0. This root 2 cancel. That is root 2 x square plus x plus root 2 equals to 0. It is the form of ax square plus bx plus c equals to 0. A is equal to root 2, b is equal to 1, c is equal to root 2. A is equal to root 2, b is equal to 1, c is equal to root 2. For this equation we have one formula. The formula is x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. X is equal to, so b value is 1, minus 1 plus or minus square root of b value is 1 minus 4 into a value is root 2 into root 2 divided by 2 into root 2. That is x is equal to minus 1 plus or minus square root of 1 minus 4 into, so root 2 into root 2 whole square. Root 2 whole square means that is root 2 whole square divided by 2 root 2. Square root cancel. X is equal to minus 1 plus or minus square root of 1 minus 4 into 2 divided by 2 root 2. X is equal to minus 1 plus or minus square root of 1 minus 8 divided by 2 root 2. That is 1 minus 8 is minus 7. X is equal to minus 1 plus or minus square root of minus 7 divided by 2 root 2. So this can be written as minus 1 plus or minus, minus 7 means 7 I square. So square root of I square is I. That is plus or minus I root 7 divided by 2 root 2. This is the solution for this problem. Once again observe here, that is x square plus x by root 2 plus 1 equals to 0. For this equation you have to reduce to alternate form. That is we can multiply root 2 on both sides. That is root 2 into x square, root 2 x square. Okay. So nimage yage illi root 2 na multiply madbekappa andre illi b value 1 by root 2 anta barutte. So b value 1 by root 2 yavat barutto nimage illi substitution ಮಾಡಿದಾಗ ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ನಿಮಗೆ ಹಂಗೆ ಮಾಡಿದ್ರು ಸಹ ಆನ್ಸರ್ಸ್ ಇರುತ್ತೆ, ಬಟ್ ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಷನ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಸೊ ನೀವು ಈ ಫಾರ್ಮ್ ತಗೊಂಡ್ರೆ ನಿಮಗೆ ಈಸಿ ಆಗಿ ಬರುತ್ತೆ. ದಟ್ ಈಸ್ ರೂಟ್ 2 ಆನ್ multiply root 2 on both sides. Root 2 x square plus x divided by root 2 into root 2 plus root 2 into 1 root 2 equals to 0. It is a form of ax square plus bx plus c is equal to 0. A is equal to root 2, b is equal to 1, c is equal to root 2. We have formula, that is minus b plus or minus square root of b square minus 4ac divided by 2a. x is equal to minus 1 plus or minus square root of 1 minus 4 into root 2 into root 2 divided by 2 root 2. On simplifying, that is on simplifying, you will get minus 1 plus or minus 1 minus 4 into 2 divided by 2 root 2. 4 2s are 8, 1 minus 8 is minus 7. Minus 1 plus or minus square root of minus 7 divided by 2 root 2. Square root of minus 7 is minus 1 plus or minus high root 7 divided by 2 root 2. Next, we will move on miscellaneous examples. Okay, so in this chapter for board level they will ask miscellaneous examples also. So now we will move on miscellaneous examples. I mean the chapter is completed. So complex number Chaitra madam already completed and quadratic equation completed. Okay, so now we will move on miscellaneous examples. That is MISC examples. So in MISC examples also important for board exam. That is, first problem is find the conjugate. Find the conjugate. Find the conjugate of 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus I. So now here 3 minus 2i divided by 1 plus 2i, that is 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus i. Now here we have to find the conjugate separately, that is 3 minus 2i, 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus. That is, find the conjugate of 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus I. I mean this one as it is you have to write, that is 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus I. Just we have to multiply here, that is 3 2s are 6. So 3 2s are 6, 3 3s are 9 plus 9i and again 2 2s are 4, that is 2 2s are 4, 3 2s are 6, 3 3s are 9i and again 2 2s are 4 minus 4i and again minus into plus minus 2 3s are 6 I square divided by, that is 1 2s are 2, 1 into I minus I, 2 2s are 4 plus 4i, that is 2 into 1, that is minus 2i square. And again this can be written as here 6 9i minus 4i. So 9i minus 4i is 5i. Okay, so 9i minus 4i is plus 5i. That is here I square is minus 1. I square is minus 1, minus into minus is plus, that is plus 6 divided by here 2 as it is and again 4i minus I is plus 3i. So I square is minus 1. Okay, so minus into minus plus 2 and again this can be written as that is 6 plus 6 is 12 plus 5i divided by 2 plus 2 is 4 plus 3i. For this one, rationalizing, that is 4i minus 3i divided by 4 minus 3i. And again we should multiply numerator to numerator, denominator to denominator. So that is 12 fours are 48, 12 threes are 36i, 12 fours are 48, 12 threes are 36i, 5 fours are is 20i. And again 5 threes are 15 minus 15, I into I square divided by is the form of a plus b into a minus b, a square minus b square, that is 16 minus 9 I square. Okay, and again this can be written as that is 48 as it is, and again 36i plus 20i is minus 16i, and again I square is minus 1, minus into minus plus, that is plus 15 divided by 16, and again I square is minus 1, minus into minus is plus 9. 48 plus 15 is 63. 63 minus 63 minus 16i divided by 25. Okay, and again this can be written as 63 divided by 25 minus that is 16 I into 16 divided by 25. So this is a solution for this problem. Don't confuse. Observe here, find the conjugate of, okay, conjugate of this fraction, that is 3 minus 2i into 2 plus 3i divided by 1 plus 2i into 2 minus i. Just multiply, so this term and this term, and again take the multiplication of this term and this term. So and again 3 2s are 6, 3 3s are 9, 2 2s are 4, 2 3s are 6 minus 6 I square. So 1 2s are 2, 1 into I is I, 2 2s are 4, 4i, that is 2 1s are 2 minus 2i square. 9i minus 4i is 5i, 6 plus 6 is 12, 2 plus 2 is 4, that is 12 plus 5i divided by 4 plus 3i. So this is rationalize the denominator and simplifying, you will get finally 48 minus 16i plus 15 divided by 16 plus 9. 48 plus 15 is how much? 63. 63 minus 16i divided by 25. Okay, next we will move on. Find the modulus and argument of the complex numbers. Find the modulus and argument of a complex numbers. So first one is 1 plus I. First one is 1 plus I divided by 1 minus I. Next one is 1 divided by 1 plus I. Already you know. So modulus means just you have to find the modulus of this number and again modulus of this complex number. So argument is nothing but pi. Okay. So argument is nothing but of pi or pi or theta. Okay, so that pi is tan inverse of y by x. So now first here 1 plus I divided by 1 minus I is first we have to find the complex number, that is 1 plus I divided by 1 minus I. Rationalize the denominator into 1 plus I divided by 1 plus I, that is 1 plus I into, that is 1 ones are 1, so 1 into I is I, okay, and again, so 1 ones are 1 into I is I into 1 is I, and again here I into I is I square, okay, so I square divided by, so divided by 1 minus I into 1 plus I, so 1 minus I into 1 plus I, so that is 1 is the form of a plus b into a minus b, that is 1 minus I square, that is so 1 plus 2I minus 1 divided by 1 plus 1, so 1 gets cancelled, that is 2I divided by 2 gets cancelled, this is nothing but 0 plus I, 0 plus I. So and again this complex number I reduce it to 0 plus I is a form of x plus iy. First we have to find modulus of this number, modulus of this number. This can be denoted as z is equal to 0 plus I, that is modulus of z equals to square root of 0, square means 0 only, that is I coefficient is 1, that is 1 square means 1 only, square root of 1 is 1, so modulus of this complex number is 1. And argument, we have one formula for argument, so that is pi is equal to tan inverse of y by x, pi equals to tan inverse of y by x, okay. So here 0 plus I is there, no, 0 plus I, this is a form of x plus iy. X is 0, y value is 1, okay. So here x is equal to 0, y is equal to 1, that is tan inverse of, okay, what is y? 1. So what is x? 0. 1 by 0 is what? Infinity, that is tan inverse infinity. Tan inverse infinity means what? Pi by 2, okay, that is pi is equal to tan inverse of infinity can be written as tan pi by 2, okay, and again this can be written as pi by 2, okay. So now argument is pi by 2, okay. Now we will move on this problem. Next problem, that is 1 divided by 1 plus I into 1 minus I divided by 1 minus I. So that is 1 minus I divided by, so that is a plus b into a minus b form is there, that is 1 minus I square, okay, that is 1 minus I divided by 1 plus I square is minus 1, minus into minus plus, that is 1 plus 1, 1 minus I divided by 2, that is 1 by 2 minus I divided by 2. This is the complex number, okay. For this number we have to find modulus and argument, okay. So modulus of this number is, that is z is equal to 1 by 2 minus 1 by 2 I, that is modulus of z is equal to square root of 1 by 2 whole square plus minus 1 by 2 whole square, that is 1 by 2 whole square means 1 by 4 plus minus 1 by 2 whole square means 1 by 4, square root of 1 by 4 plus 1 by 4 is how much? 1 by 2. This is the modulus, this is the modulus of the your given complex number. Now come to argument, pi is equal to tan inverse y by x, that is tan inverse So what is y value? Already I told. This is a form of x plus iy. Here x is equal to how much? 1 by 2. Y is equal to how much? Minus 1 by 2. That is y is equal to, so x is equal to 1 by 2, y is equal to minus 1 by 2. That is tan inverse of what is y? Minus 1 by 2 divided by what is x? 1 by 2. So this one cancel. That is tan inverse minus 1. Tan inverse minus 1 is what? Minus pi by 4. Okay. Tan inverse of minus 1 is what? Minus pi by 4. Okay. This is the argument. Okay. Once again observe here. 1 plus I divided by 1 minus I. So that is rationalize the denominator, and again when you rationalize the denominator you will get the complex number, that is 0 plus I. Here x is 0, y is 1. Okay. That is x plus iy form. X is 0, y is 1. Just find the modulus of this number. So 0 square means 0 only. I coefficient is 1. 1 square means 1. Square root of 1 is 1. Now come to argument. Pi is equal to tan inverse y by x. Tan inverse. So y is 1. X is 0. Tan inverse of infinity. Tan inverse of infinity means pi by 2. Now come to next problem. That is 1 plus I. That is standard number is 1 plus I. Rationalize the denominator, that is you will get the complex number, that is 1 minus I divided by 1 minus I. So 1 minus I divided by 1 plus I into 1 minus I is 1 minus I square, is the form of a plus b into a minus b, 1 minus I square. That is 1 minus I divided by I square is minus 1. 1 plus 1. 1 minus I divided by 1 plus 1 is 2. 1 by, separate the fractions here, 1 by 2 minus I by 2. X value is 1 by 2, y value is minus 1 by 2. It is a form of x plus iy. Just find the modulus of this number, 1 by 2 whole square plus minus 1 by 2 whole square. Square root of 1 by 4 plus 1 by 4. 1 by 4 plus 1 by 4 is 1 by 2. So modulus is square root of 1 by 2. Now come to argument. Argument formula is what? Tan inverse y by x. Tan inverse, what is y? Minus 1 by 2. What is x? 1 by 2. Tan inverse 1 by 2, 1 by 2 gets cancelled. Tan inverse of minus 1. Tan inverse of minus 1 is what? Minus pi by 4. Next, we will move on. So very important problem. X plus iy equals to a plus ib divided by a minus ib. Prove that x square plus y square equals to 1. Very important, this one. So here x plus iy equals to a plus ib divided by a minus ib. And again you have to prove that x square plus y square equals to 1. Just you have to take first, what is x square plus y square means? When you will take x plus iy into x minus iy. X plus iy into x minus iy, it is the form of a plus b into a minus b. So a square is what? X square. B square is minus I iy whole square. That is I square is what? Minus 1. Minus what? Plus. That is x square plus y square. Now I have to find x plus iy. The given x plus iy, you have to rationalize, and again we have to find x minus iy separately. That is x plus iy equals to a plus ib divided by a minus ib into a plus ib divided by a plus ib. Now it is a form of a plus ib into a plus ib, that is a plus ib whole square. Otherwise we can take the multiplication, no problem. A into a square plus a into ib plus aib plus ib into a plus aib or iab, both are same. iab, ib into ib, that is plus into plus, that is ib into ib, I square b square divided by, that is a plus b, a plus ib into a minus ib, that is a square minus ib whole square. See, a plus b into a minus b form. So a square, b value is ib whole square, that is a square plus iab plus iab plus 2aib. Okay, so I square is minus 1 minus b square divided by a square, I square is minus 1, minus into minus, plus a square plus b square. This is x plus iy value. And again x minus iy, so I mean the action is of x plus iy. Now come to x minus iy. X minus iy. Similarly we will write x minus iy is a square minus b square minus 2aib divided by a square plus b square. And again this can be written as a square minus b square divided by a square plus b square plus 2ab divided by a square plus b square. And again this can be written as a square minus b square minus a square minus b square divided by a square plus b square minus I into 2ab divided by a square plus b square. Now come to, that is x square, I have to prove x square plus y square equals to 1. So x square plus y square can be written, it can be written as x plus iy into x minus iy, that is x plus iy into x minus iy. That is x plus iy value, I have to take this, that is a square plus 2abi minus b square divided by a square plus that is x plus iy is a square minus b square plus 2abi divided by a square plus b square. X minus iy, x minus iy I have to take this, that is a square minus b square minus 2abi divided by a square plus b square. Just you have to take the multiplication numerator to numerator, denominator to denominator. Okay, so that is a square into a square, a to the power of 4. A to the power a square into a square, a to the power of 4. A square into b square minus a square b square. A square into 2ab minus 2a cube bi. And again 2abi into a, that is plus 2a cube bi. 2abi into b square is minus 2ab cube I. And again b square, come to b square. So now x plus high y, x plus high y is a square minus b square, a square minus b square divided by a square plus b square plus I into 2ab divided by a square plus b square. So x minus iy is a square minus b square divided by a square plus b square minus I 2ab divided by a square plus b square. It is a form of a plus b into a minus b. A plus b into a minus b. So a plus b into a minus b is a square minus b square. That is, a is this, b is this full value. Okay, a square minus b square, a square plus b square whole square minus, so here that is 2ab I divided by a square plus b square whole square. That is, so here a square minus b square whole square minus, okay, so here 2 square means what? 4. 4 a square b square I square divided by, so a square plus b square whole square. So that is, and again, so a square minus b square whole square, it is a form of a minus b whole square. That is, that is a square minus b square minus, so here I square is minus 1, minus into minus plus, that is 4 a square b square divided by a square plus b square whole square. We formula, that is a minus b whole square, a minus b whole square plus 4ab equals to a plus b whole square. Okay, so this is a formula already studied in SSLC. A minus b whole square plus 4ab equals to a plus b whole square. So now instead of a, what is there here? A square. Instead of b, what is there? B square. That means a square minus b square whole square plus 4 a square b square equals to, here also it becomes what? A square plus b square whole square. This can be, this whole term can be written as what? A square plus b square whole square divided by a square plus b square whole square. This one cancel, is equal to 1. Okay, into a minus b, this is done short question. So that is x plus iy equals to a plus ib into a plus ib divided by a minus ib. We have to prove that x square plus y square is equal to 1. So x square plus y square is nothing but what? It can be written as x plus iy into x minus iy. So x plus iy, they given a plus ib divided by a minus ib. So rationalize the denominator, you will get what? A square plus 2aib minus b square divided by a square plus b square. And again here separating the real terms and complex term, that is a square minus b square divided by a square plus b square. So plus I 2ab divided by a square plus b square. Similarly we have to write x minus iy a square minus b square minus 2aib divided by a square plus b square. Similarly here a square minus b square divided by a square plus b square minus I 2ab divided by a square plus b square. And again you have to take x plus iy into x minus. I have to prove that x square plus y square equals to 1. No, instead of x square, I mean take LHS, you have to prove RHS. Okay, that is x square plus y square is nothing but what? X plus iy into x minus iy. So that is a square minus b square. I mean instead of x plus iy you have to write this full term. Instead of x minus iy you have to write this full term. And again it is a form of a plus b into a minus b. So a plus b into a minus b is a square minus b square. And again a square minus b square whole square, 2 square is what? 4. A square b square I square. And again LCM is what? A square plus b square whole square. I square is what? Minus 1. Minus into minus plus. A square minus b square whole square plus 4a square b square divided by a square plus b square whole square. We have one formula: a minus b whole square plus 4ab equals to a plus b whole square. ಇದನ್ನು ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ a ಪ್ಲಸ್ ಬಿ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಫಾರ್ಮ್ನಲ್ಲಿ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತೆ. ಓಕೆ, ಅದಕ್ಕೆ ನಾವು ಈ ರೀತಿ ಬರ್ಕೊಂತೀವಿ. a ಮೈನಸ್ ಬಿ ಹೋಲ್ ಸ್ಕ್ವೇರ್ plus 4ab can be written as a plus b whole square. Instead of a, what is there here? A square minus b square whole square plus 4a square b square equals to a square plus b square whole square. Instead of this we have to write a square plus b square whole square. So this term and this term cancel. So what is remaining? Equal to 1, that is equal to RHS. Okay, so now in this session, so we have to discuss miscellaneous examples and one problem on complex number. So that is quadratic equation. So complex numbers and quadratic equation PU syllabus is completed. So now next session onwards, so we will discuss about objective about complex numbers. Thank you one and all.